चलो दोस्तों, वेलकम टू गेट वाला. This is Satish Kumar, Faculty of Electrical Measurements and Instrumentation. The subject measurement is there for electrical engineering students as well as IN students. So, on Gate Wallah, I am going to deal exclusively gate electrical, and of course, the students who are preparing for the IAS, they also can follow this content. And if you want to understand the gate pattern of the electrical measurements, first you should have a blueprint of the syllabus. So, before entering into the topic measuring instruments, just as a glimpse, I want to tell you the syllabus. The major syllabus of the measurements can be categorized into two ways. One is the electrical measurements, other one is electronic measurements. So, first let me talk about something about the syllabus, then I will go to the content. So, the measurements is categorized as majorly two parts, electrical measurements as well as electronic measurements. Electrical measurements, electronic measurements. Under the electrical measurements, we are going to have first measuring instruments. Measuring instruments, MI stands for measuring instruments. Of course, we are having the bunch of instruments under the measuring instruments. I will give you the list. Then comes the bridges. Under the bridges, we are having the AC as well as the DC. Okay, dear. And next comes the measurement of resistance. Resistance measurement, low, medium, and high. And next comes higher version of instrument CTPT, and next comes the error analysis. So, these are the basically under the electrical measurements, and I will give you the list of the measuring instruments. Electronic measurements, we are having the Q meter, DVM, CRO. These are the major topics in electronic measurements. Of course, instrumentation syllabus slightly different, one or two topics added extra. I will explain that later. That is like cables and units and dimension standards, like that. So, this is the standard syllabus, but when it comes to the measuring instruments, we are having the bunch of measuring instruments. But what is that bunch? I will tell you in the, that is only my demo today. Under the measuring instruments, basically we are having major instruments are these. These major instruments are PMMC, moving iron, electromagnetic moving coil, electrostatic voltmeter. Okay. Again I am repeating the full form. PMMC stands for permanent magnet moving coil, and MI stands for moving iron, and EMMC stands for dynamometer. So, this is also called as dynamometer. Electromagnet moving coil, electromagnet moving coil, and it is also called as dynamometer, and ESVM stands for electrostatic voltmeter. In addition to this, we are having some extra instruments like energy meter bhi hai. So, we are also having energy meter, we are having energy meter, and we are having the potentiometer, and we are also having the current transformer and potential transformer, and we are also having the thermal instruments, my dear. What we have? We also have thermal instruments. So, these are the set of instruments. In this set of instruments, a list of formulas are available. Formulas for the deflection torque and the controlling torque. And especially now, these formulas every year we are going to get one or two questions on the constructional features and also the deflection torque and current measurement. So, if you see what is the deflection torque and controlling torque formula. So, if you see the deflection torque for the PMMC, permanent magnet moving coil. For permanent magnet moving coil, the deflection torque is given by the formula TD is equal to BNA. What is this formula? Deflection torque is given by BNA. B for magnetic flux density, I is the current passing through the coil, N is the number of turns, A is the area of cross section. and Tc stands for Kc theta. Okay. So, this is the deflection torque formula. Are you clear? So, this is deflection formula and this is the controlling torque formula. So, all together theta is proportional to the current. Theta is proportional to the current. Next comes the MI instrument, which is also called as moving iron. The moving iron deflection torque is given by 1 by 2 I square dl by d theta, 1 by 2 I square dl by d theta, and the controlling torque Tc is equal to Kc into theta, and this particular theta is proportional to I square. This particular theta is proportional to I square. Next comes the one more instrument, that is what we call as EMMC. The EMMC is also called as dynamometer, and the deflection torque for this is given by I square into dm by d theta, I square into dm by d theta, and the controlling torque is equal to Kc into theta. Controlling torque for each and every measuring instruments almost remains the same. So, here the theta is proportional to I square, at the same time it is proportional to V square here also, but the speciality of this particular dynamometer is it is suitable to work like a watt meter, it is majorly suitable to work like a power measurement. So, it is proportional to average power, that is VL IL cos phi. So, that is a fundamental reason why the dynamometer is best suitable for the power measurement. Next comes the electrostatic voltmeter. Electrostatic voltmeter formula, deflection torque is equal to 1 by 2 V square dc by d theta, and the controlling torque is equal to Kc theta. Okay, and this theta is proportional to V square. It is also suitable for both AC and DC. So, these are the list of the instruments. Major list, I want to tell major list. Of course, energy meter is there, CTPT is there, potentiometers are there, but regularly we are getting the questions from this. Okay, dear. So, one more formula I want to tell, which is coming from the range extension of the meters. Range, are you clear? Yeah, range extension of the meters. So, what is the range extension of the meters? Just listen the range extension of the meters. So, if you want to take the PMMC as ammeter, PMMC as ammeter, and how its range can be extended further. So, if you take this as the meter, so this is our meter current Im, and this is the meter resistance Rm, and for this in parallel we are attaching the shunt resistance to extend the range. So, this is the RSH. So, this is our I and this is our ISH. So, question can be asked, what is the range of this shunt resistance? What is the value of this shunt resistance, so that the current range can be extended for certain value to the certain value. So, this RSH shunt resistance is given by Rm by M minus. I am not going for the derivation, but of course, it can be derived. Rm by M minus 1. So, here what is M? This M refers to the multiplying factor, my dear. So, M is taken as ratio of I by Im. The meter current as of now, that is Im, and for which range you want to extend the current, that is I. Next, similarly, if you want to extend the PMMC as voltmeter, if you want to extend the PMMC as voltmeter, if you want to extend the PMMC as voltmeter, so this is our voltmeter Vm and this is our Rm, and in series we are attaching a resistor. So, this is a Rsc series resistor. Okay. So, this particular series resistor Rsc is given as Rm into m minus 1. Rsc is given as Rm into m minus 1, where here the m is again the multiplying factor. So, this m is given by V by Vm, V by Vm. So, this is the meter voltage and this is the voltage for which the range has to be extended. Understood here? So, these are the bunch of the instruments. So, this is a PMMC ammeter and this is the PMMC voltmeter for which you want to extend the ranges. So, this is what we call as multiplying factor and this is what we call as multiplying factor. Like this, each and every measuring instrument is having a set of formulas. If you just practice those formulas and if you can remember where these formulas can be applicable and when to use, when not to use, if you know clearly, then automatically what happens dear? Easily you can get the score. And in my classes, I am going to give a systematic approach. It's not like a mess. I will take a particular topic and I will go into the depth of that particular topic and I will save your time of preparation, how to prepare short notes and how to get the formula and from that how to apply in the exam. And if you see, for electrical and instrumentation students, on an average, we are getting 8 marks. How many marks? 8 marks we are getting in the measurements. And I assure you in the measurements, those 8 marks compulsory you are going to score very well. Okay? And if you see the topic wise, as I told you, the measuring instruments is one of the important. One is the PMMC, moving iron, dynamometer, energy meter, and the list of formulas and the range extension. And the next most important thing is the bridges. So, bridges also one of the important thing I want to tell you. So, in the bridges, let me write here bridges. Bridges are fundamentally suitable for measurement of resistance and of inductance, capacitance. They are broadly classified into 2 categories. AC bridges as well as the DC bridges. AC bridges as well as DC bridges. AC bridges majorly suitable for measurement of resistance, inductance, capacitance, frequency. Whereas a DC bridge is majorly suitable for resistance measurement. AC bridge, list of bridge are there. One is the Maxwell inductance capacitance bridge, Maxwell inductance bridge. Next comes Maxwell inductance capacitance bridge. Next comes Hesse Bridge. Next comes Anderson Bridge. Next comes Owens Bridge. Next comes De-Sauty Bridge. And next comes Sharing Bridge. And the last one, Wien's Bridge. See the big list. But I will tell you the technique, what bridge, for what purpose, when to use, when not to use. So, these are fundamentals for the AC measurements. They will use the AC supply and we have to use self inductance and capacitance, choice of bridge selection based upon what you want to measure. And if you go for the DC bridges, we are having the Wheatstone bridge and we are also having the Kelvin's double bridge majorly, Kelvin double bridge. So, these are the bunch of bridges. Understood here? So, these are the bridge list. Clear? So, when to use these bridges, how to remember? I will tell you a shortest technique, my dear. So, how to remember the shortest technique? Listen. So, if you see the shortest technique, one second, I wrote, yeah, sorry. If you see the shortest technique here, Maxwell inductance bridge, they are suitable for what measurement? They are suitable for self inductance measurement. They are suitable for self inductance measurement and whose Q factor is medium Q factor. That means greater than 1, less than 10. So, the Q factor is medium Q factor. How to remember, sir? Maxwell first letter is M. So, Q factor also medium M. Got it? And the next comes Hesse Bridge. And if you see the Hesse Bridge, this is a self inductance and the Q factor must be greater than 10. So, it is suitable for high Q factor. It is suitable for high Q factor. You can remember Q value greater than 10, higher value. Next comes Anderson Bridge. Anderson Bridge is also for self inductance measurement, but it is Q factor for the coil should be less than 1. So, it is lower Q factors. For higher Q factors this is, and for lower Q factors this. Okay. Next comes the Owens Bridge. Owens Bridge is fundamentally for self inductance L incrementing or decrementing, L plus or minus delta L, L plus or minus delta L, incremental self inductance and decremental self inductance. It is also Q factor less than 1, so lower Q factors. Next comes the de Sauty Bridge, majorly de Sauty's Bridge. This is suitable for the capacitance measurement. Of course, the D stands for double here, double. We are going to use 2 capacitors, but 2 capacitors, that problem is eliminated in the next coming bridge. D, you can remember D for double. So, it is for capacitance measurement. It is also suitable for dissipation factor measurement. Capacitors fundamentally will follow loss factors. So, that is why it is suitable for dissipation factor. Okay. So, this is for M, this is the de Sauty. Next comes the sharing bridge. Sharing bridge is also for capacitance. So, it is also suitable for dissipation factor. Dissipation factor. And next comes the Wien's bridge. Wien's bridge is suitable for frequency measurement. It is basically is used in oscillators. Got it? So, this is the blueprint. Like this, I will give you the content blueprint for each and every instrument. I will give you a set of blueprints so that your time will be saved. And of course, you have to practice based upon this particular thing. You have to practice. See, on this particular gate Wallah platform, every lecturer, every faculty is burned and having a competitive fire in their hearts to give the best to the student community. Every faculty, whoever are they here, they came from the different background, but the struggling background. In their life, they have seen very much struggle and they know the struggles of the students very well. At each and every subject, what every student is going to face the struggle, so that is already experienced by these experienced faculties on our gate Wallah. I am going to come on electrical platform. This time I am going to teach the measurements exclusively for electrical and also for instrumentation student. Coming to the instrumentation students, there are some set of new topics. Definitely other people will neglect, but those new topics only are important for the exam, especially for instrumentation. And for instrumentation, the syllabus is very vast because they are also having the machines, they are having the EMT, and in instrumentation many new subjects have been added for them. So, time is most important for them to complete the total syllabus. So, that is why I suggest each and every aspirant of gate level, they can follow the gate Wallah classes, live classes. We are going to come soon on our platforms. We are going to announce the batches. Myself, Satish Kumar, I am going to discuss the electrical measurements for you and also electronic measurements, that is CRO, Q meter, DVM right now on the gate platform, and also instrumentation students. I am going to discuss the total core subjects: sensors and industrial instrumentation, process control instrumentation, optical instrumentation, microprocess, microcontrollers, PLC, SCADA. And electronic students, I am going to discuss computer organization and computer architecture because my specialization in MTech is embedded systems. I have studied from chip level to the architectural level and interfacing level of the CPU to the various devices. And regarding the CO also, I am submitting a demo under the CS department. You can go through it. Having the 16 years of teaching experience, I assure you, your confidence level for building up the gate preparation will be boosted by my content, and I wish you all the best for your gate preparation on this our Gate Wallah platform. Soon we are going to meet. Thank you and all. Well prepared for preparation, the best quality. Please log in on the Gate Wallah. Thank you very much.